Okay, so let's see if we can get on the same wavelength here. So for part A, what is the most likely value? Now you did it logically, perfect, love it. But make sure you could also do it using the concept from the section, which was the idea here of the Bernoulli trials is either success or failure. So we can define success as one that has more calories, and then failure would be the ones who have, so as known that 67% of patties produced in the factory contain more than, so then these would be not more than the 1,000 calories. So we know the probability here, the probability of them having more calories is 0.67. And so therefore the probability of them not having would be 0.33. Try again, 0.33. There we go. So how can I calculate this? Well, if you knew you already wanted to try the 34, you could say, well, it's 50 NCR 34 times, so the probability, what is the probability of it having exactly 34? And that would be 50 choose 34 times the probability of success, 67 to the 34th. Let me kind of get a separation in here. Actually, you know what? We don't need this anymore. You got the idea. I'll move it. Remove it. All right, there we go. So then times the probability of failure, so it's 0.33 to the 50 minus 34. And that will give you the probability of this event. And then you could compare this to the probability of 33 of 35 and see which one has the highest probability, and there's your answer. So now what's the quick way to do this, because that would be a lot to do by hand. So we can always use our graphing calculator to help us out with this. So what I'm going to do here is go to my y equals. I like my y equals. Let me drag this down. I think it might be off your screen a little bit. Alright, so what I'm going to clear that out. I'm going to type in this formula, but in a sort of generic way. We know that there's 50 patties. Now we're going to go here to our NCR. Now the number of patties that we are saying is going to have more is going to be the thing that's changing, so we're going to call that x. And just to be safe, I am going to put some parentheses around this, just in case the calculator does something funky on me. There we go. So now it's 0.67, and then we're going to raise that up to the 34th. Oh, excuse me, not to the 34th. That's the number that's changing, so that's going to be x. There we go. Then the next number is the probability of it not having more, which is 33%, and that exponent is going to be 50 minus the number that do have more, so minus x. So now what I can do is I can kind of cheat. Let's see what their table looks like. Let's go to our table set, change it to, well, let's just jump to where you think you're going to be. Let's do counting by ones. Clear. Counting by ones. Starting at 33. I didn't want a graph, I want a table. There we go. So now we can see all the probabilities in a flash. And you can see the probability of having exactly 32 is just over 10%. Probability of 33 is just over 11%. 34, just slightly over that. 35, oh, we're going back down. So therefore 34 has the highest probability. So hopefully now that gives you a hint to, or an idea of how you can approach this one. So the next one is saying there's approximately an 82% chance that a batch of 50 calories contain, well, you said 34, but that's not right, contains blank or more patties with more than 1,000 calories. So this is the probabilities of, the probability of 32 having more, 33 having more. Where's that low number? Where's this number? So when we add them all up, we end up with 82%. All right, I hope that's enough of a hint. I hope that gets you rocking and rolling. Best of luck.